The problem is clear. Literally, 75% of all glass that enters the global waste system sadly ends up in landfills. This is because high recycling rates are difficult to achieve with glass due to the high operating costs and the low value end markets. Furthermore, up to 30% of glass waste leaving recycling centers cannot even be processed because of size or color. At the same time, in Colombia, fertilizers account for 12 to 35% of agricultural production costs, and the crop nutrition sector generates 2.6 million tons of carbon dioxide each year. Now, you might be wondering what's the connection between these two issues? The answer is Lup Colombia. Hello, I am your host, Mike Lake, and in this preview, I will be talking with Caitlin Oliver about how her Colombia-based company is transforming glass waste into fertilizer.
Innovation, resiliency, discovery. Join Mike Lake, President and CEO of Leading Cities, as we explore the technologies shaping the possibilities of our future with a preview of tomorrow.
Hello and welcome, Caitlin. Thank you so much for joining us for this episode of Preview of Tomorrow. And as always, I want to welcome all of our listeners and viewers, and thank you for tuning in yet again. Today, it's my real pleasure to introduce you to Caitlin Oliver. She is the CEO of Lup Colombia. This is a company that is taking a data-driven approach to designing market and community-centered solutions for transforming glass waste into low-carbon products. Now, Caitlin, before we get into this massive issue of recycling glass and the solution you've created, tell us a little bit about yourself and how did this all come to be?
Yeah, sure. So my background is in environmental engineering. I'm from Canada, and I moved to Colombia, oh my gosh, I guess almost 4 years ago now, to work on waste projects. I love recycling. I love waste management. It's my passion. And when I was there working in this foundation, I met my business partner, Benedict Faure. She's a materials engineer from France. And we just connected on our values. We realized there's a huge problem of glass waste just either ending up in marginalized communities or being landfilled. And so we set out to work on that.
And for those who are listening, to get a sense of how big of a problem is glass waste.
Yeah, I mean, it's always difficult to get the data on waste because it's being measured and there's so many people touching it along the way. But so through data from the World Bank, we've estimated about over 10 million tons of glass waste is being landfilled in Latin America. But even just region to region, depending on if there's any glass manufacturers there or processors rather, there's majority of waste going to landfill. In Cartagena, it was over 45,000 tons annually going to landfill. So. It's a problem.
I mean, as we're all aware, there are recycling efforts, and glass is one of those materials, in theory, that's getting recycled, but there's a reality to that as well. And not all glass that is recyclable is recycled. Is that right?
Yeah, I think that's important to touch on is the theory versus reality, and especially when it comes to waste. And I mean, turning glass into new containers is important, and it is, circular. However, it's not happening to the level that I think maybe people believe that it is. And so, I mean, that's certainly the case in Colombia and in other regions and countries that we've worked in. It's challenging as a heavy material. So if you're doing long transportation, that's a lot of costs and CO2 emissions. It has to be color separated if you're going to turn it into new containers. And that in the case of where we're located, that relies on a low wage workforce to manually separate the glass. So I mean, there's obviously issues with that. And just the processing costs of glass waste. So it's obviously great, but there does need to be complementary solutions to ensure that no glass waste is going to landfill, because in our opinion, that's a terrible waste of resources, finite resources. So
absolutely. And when you talk about a amount of glass that it just isn't being recycled, do you have a sense of how much we're talking?
Yeah, so I mean, in Cartagena, about 45,000 tons that we're aware of, but glass recycling rates can be as low as 10% in some places. I mean, it's challenging. And that's also looking at container glass. There's also flat glass, there's car windows. There's a number of different types of glass that are just not necessarily finding the end markets or the right technologies to process them. Yeah.
So that brings us to the important point of what you've developed and the innovative solution you've created. So tell us a little bit about Lup Colombia and what you are doing with this glass waste.
Yeah. So we started over 2 years ago, and we just first started doing a lot of market research to say what are the other kind of end markets we could consider for glass waste that have high impact. So that's another component of what we want to do is obviously divert waste from landfill, but also transform it into something of high value, something that can actually help to reduce greenhouse gas emissions, that can support key industries such as construction and agriculture. So that was something. So we spent a while doing market research, engaging with various people on the value chain, from waste collectors to industry to government, to really see what is the best way. This is these types of solutions that require a lot of collaboration from different types of stakeholders. So it was after a lot of trial and error where we discovered kind of the best products, and then also found technologies that we liked. And so we don't do our own technologies. We like to think that we, instead of reinventing the wheel, we find technologies and innovations that we really like and try to put them all together and come up with solutions that work for the local context, because what works in Canada won't necessarily work in Colombia or whatever, right? So it's about customizing, but also streamlining the process so that it's quicker to develop these solutions.
Well, and that's an important point I want to just emphasize for a moment, is that every community is different. It's business culture, social context, environmental issues or impacts. I mean, so how is it that you actually do customize this? And what are some of the maybe red flags or important considerations, I should say, to be mindful of?
Yeah, I just want to quickly give a shout out to Crystalline Technologies. We're the exclusive distributors for their technology in Latin America, but also the CEO, Steve, has been an amazing mentor to us and really taught us a lot about waste recycling and glass recycling. So, because it is definitely challenging to kind of put all the pieces together. Side note, but yeah. So how we started was really looking at what is the problem, and I think all entrepreneurs go through this, is like your solution maybe is not the best solution, and like really looking at the problem and being like fall in love with the problem. What is the problem? And then the solution will reveal itself to you. And so we did a lot of working with the waste collectors to see like what is the price range that you need to be paid that fairly compensates you for your work. And then consistent revenue. So when we started with that, first of all, when you're paying for glass waste, it means that we have to, and then your processing costs, we're going to have end markets that are higher value. And so we really had to start looking at the balance of like the cost that we have to pay versus what we can basically charge for these products. And so there was a lot of going back and forth with that. And then also looking at the markets in the area, so we looked at construction, agriculture, water filtration, looking at all the different markets to see what is actually like a good market, what are we replacing, who are our competitors. So there's a number of looking at.
So on that note, let's talk a second about the actual products you're creating from this glass waste, and why it's so much more effective as a means of recycling.
Yeah, sure. So we've really honed it in Colombia on silicon fertilizer. So silicon fertilizer, like a soil conditioner. And so basically that's taking glass waste. And the great thing is we can use all different color glass, like commingled. You don't have to do separation on all different types. We can do flat glass, container glass, and then basically convert it into pellets that you can either apply to the ground or you can put it in your spray system, irrigation system. And so the great thing about that is you can reduce your nitrogen fertilizers, and nitrogen fertilizers are obviously contribute to nitrous oxide. So what we're working on, is basically be able to support the crop nutrition sector with reducing some of their greenhouse gas emissions, and also support farmers and agribusinesses in the area with increased crop yield and soil quality.
So explain this a little bit to me, and you don't have to go too technical, but how do you go from waste glass of all shapes, sizes, colors, whatnot, to fertilizer?
Yeah, so I mean, glass is composed of about 70% silica, and from there we can go through the process of converting into silicon when it's planted when it's in the ground, and silicon is an important crop nutrient. So basically the process is collecting the glass, of cleaning it, of sizing it, of reducing the size, of pelletizing, and or depending if you want to put it in whatever form you want to apply it. And yeah, it's a crop nutrient. It's simple. It doesn't replace all fertilizers, but we're able to reduce some of the more less environmentally friendly fertilizers, and that's our goal.
And what is the impact on the crop?
Yeah, we're working with a partner in Australia, and so they've done a number of studies that have shown an increase in crop yield between 10 and 20%, depending on the type of crop. And so that's something that we are working to hopefully start our field trials in Colombia in October, November, with key crops in the region. So it's already trials have been done on corn and rice. We want to extend and do in coffee, but we also want to test on other crops that are more common in the area.
Which I know, we all know, I think, that the population continues to grow worldwide. And, with impacts of climate change, I mean, one of the impacts, a degree and a half to 2 degrees increase in temperature, Celsius that is, can have tremendous impacts on crop yields. So this is an interesting way of combating that and making sure that we do have the yields we need, the production we need of food to sustain a growing population worldwide. I'm just saying that the ripple effects that you're creating and the impact on potentially a global scale are tremendous. And it all starts with glass waste. Who knew?
Yeah, who knew? Yeah, no, and also I think in terms of just, I think if COVID has shown us anything, it's that you need to be able to have, more security in terms of like what you're producing. And because so much of like nitrogen fertilizers, the ingredients are imported in, it's nice, like anything that we can contribute to, we can create, a fertilizer for farmers locally. I think is certainly useful to have more control over, your production.
So is your vision to continue to scale and grow, but you would have to have or want to have local conversion of glass waste into this fertilizer?
So our kind of a vision of how we want to do it is this pilot plant in the Caribbean coast of Colombia will be our initial plant, but also to kind of turn that into an R&D center so we can further test other markets. So we have explored with a partner in Central America using recycled glass as a concrete additive, and that's had good lab results. And there's other people who have done it. University of Sherbrooke in Canada, for example, are pioneers in this application. So we are looking at other opportunities, but we really need this initial pilot plan. We know that the silicon fertilizer would be the best market for the area, and we can further test other products because, silicon fertilizer works in Colombia. It won't necessarily work in another place if they don't have a lot of agriculture. And so that's one kind of aspect of the pilot plan, as well as to demonstrate the technology and to be able to send samples and products to other projects. So I think that's something that we didn't quite realize until we were doing our own pilot plan and then also working on some tech distribution projects in Latin America, is how tricky it is to develop something when you need to do field trials and you need to do lab trials, but you don't have any of the product to do the trials, and you need to do the trials to get the customers. And so there's a lot of, chicken and eggs type stuff. So we really want to be able to have this plan to be able to support other projects, and then to partner with local partners, whether it's end users like a concrete company, whether it's an agribusiness, to partner with, whether it's a government, to partner with them to develop and replicate this model in other places. So.
And in terms of the yield of your own products, is it a 1-to-1 ratio? How does that work? In other words, does 1 million tons of glass waste equal 1 million tons of fertilizer or other product, or what is that ratio?
Yeah, so we can, depending on the crop, it can reduce nitrogen fertilizer by up to 20%, but we've been kind of doing calculations more in like the 10% range. So for example, using glass-based fertilizer, you can reduce the greenhouse gas emissions of nitrogen fertilizer by 16 to 22%, and that's just for a 10% reduction. Wow. And that's factoring in also like the transportation of some of these for NPK, nitrogen, phosphorus, potassium fertilizers, those main ingredients coming from Europe or other places, and then having to come all the way into Colombia. Like, so we looked at the entire value chain and said, like, we can actually significantly reduce, particularly since we're focused on the departments of the states that are nearest to where the plant will be located.
That's incredible. So, looking forward 10, 20, 50 years down the road, let's assume that Lup Colombia is around the world, and every bit of glass waste is now being properly recycled. What does that mean? What does it mean to a user, the average person? What does it mean to society, or even to the global environment?
Yeah, so I mean, we say like we want to support customers from project ideation to implementation, and our vision is just that there is no glass waste ending up in landfill. That there's none, and to really the only way we can do this is to be collaborating and forming connections with all across, from government to waste collectors, everyone forming these connections. And so ideally, it's also considering what are the implications of these products long term. What is the data behind this? And so we want to support customers with their feasibility studies, with being able to decide, make the right choice for the project that they're doing, to do technology distribution with them, to sell them technology, and then to partner with people on building plants. So we're focused in Colombia and Latin America for now, but we really see that what we're doing is business model can be replicated elsewhere, because it's the systemic design approach, and it's also the data-driven approach that we think that makes it applicable.
Well, I want to congratulate you on all this effort, because there's no doubt the more we can recycle any of our waste, the better off, the more circular it is, the better off the world, or the planet, and all of us as individuals are. So thank you so much. On the note you just left us on, how is somebody who might be interested in learning more or partnering or whatnot, how do they get in touch with you? How do they learn more?
Yeah, definitely. So, and we're certainly open to hearing from governments and from technology manufacturers, specifically glass processing manufacturing, and entrepreneurs in the recycling space. So if anyone wants to reach out, they can at hola@lup, L-U-P, Colombia, it's O, not U, .com. Just spelling, people always get that mixed up.
Yes, so true, so true. Well, thank you so much for joining us, and thank you for this work. I mean, it really is making a difference in the world. It's been an honor and a pleasure to have you on Preview of Tomorrow.
Thank you so much, Michael.
And thank you for tuning in to this episode of Preview of Tomorrow. Listeners like you are essential to advancing our efforts to drive resiliency and sustainability for all. I ask that you give us a rating on Apple Podcasts or whichever streaming platform you prefer. Your feedback helps us to grow and share these brief previews of what life in the future can be. In addition to thanking our guest today, I want to thank Peter Roy and Demetria Bridges for making this podcast possible. If you enjoyed this episode, please subscribe and encourage others to also join us each week in previewing the possibilities of tomorrow.
Preview of Tomorrow is brought to you by Leading Cities, a global nonprofit driving resilience and sustainability for all by unleashing the potential of the world's cities. Join them at leadingcities.org.